Yeah, so what we're going to look at next is called the rule of product. So instead of having these two distinct cases that are both acceptable, what we're going to have now is this action that has two sub-actions. So you're going to do task A, then task B. So the complete action consists of more than one thing every single time. And so in this case, if you have m ways to complete A followed by n ways to complete B, if we want to do A then B, then it's going to be the product of their numbers, so m times n. So the exact same example that we had done in the rule of sum, Leonard's making macarons. The cookie part is either vanilla or mocha flavored. The filling will be either chocolate cherry or caramel flavored. How many different kinds of this macaron cookie can he make? So in this case, what we can do is organize this into task A, then task B. So that's his, if we want to make the macaron, it consists of choosing the cookie. That's not how you spell cookie. So I'll call it task A, and then choosing the filling, which will be task B. So again, for this, there's a small little requirement that we do need to think of in this situation. The choice of task B should not matter what task A was. So I'm going to just go and add that to the description above. Okay, so the options for the second task should not depend on what the first task was. So for example, what we're saying with these macarons is that any of the cookie part can go with any of the filling parts. So it doesn't matter what we've chosen for the cookie, any filling is going to work. So what we would do here, we would choose the cookie, task A, and so it's either vanilla or mocha. So there's two options. And I've already got those underlined for the filling parts. It's chocolate cherry or caramel. So there's three options. And so the rule of product then says that the total number of options, since it's got that word then between the action, is going to be 2 times 3 is 6. So there's 6 different cookies that can be made, which is the exact same answer that we got before. So we could potentially change this question a little bit to kind of emphasize that requirement that I put on the rule of product. So I'm going to just fix this a little bit to make it a little bit different. All right, so what I've done here now is I've added in a line that says that Leonard thinks that mocha and cherry are gross together, so he's not going to make that combo for his macaron. So now how many different kinds of macaron can he make? So in this case, our choice of cookie, so if I do cookie first and then follow it up with filling, so the problem here is that the filling is not independent from the cookie. So my filling options depend on what cookie was chosen. So the problem here is that because of this line, the rule of product actually isn't going to apply now. So I'll just do something different. So what I could do this a couple of different ways. I could either just find all the options and then subtract the bad one. So we could do that. That would be one way of solving this. So there's 6 options total, which we already knew from before, but one gets rejected. So 6 minus 1 is 5. Or we can revert back to that rule of sum. So, or what we could do is break it into vanilla or mocha. And so for the vanilla, there's 3 options. And for the mocha, because we can't have the cherry with mocha, there's only 2 options left. So we get 3 plus 2 equals 5. So we get to the same answer either way. It's just kind of a matter of how you think about things. And actually, in a lot of cases, it's going to be easier to subtract the rejects than it is to try to add together all the good combinations. So do another example. Oh wait, so one last example here for the rule of product. This is going to be a pretty common one. Every week, George arranges his 5 garden gnomes in a different order on his front steps. How many ways can he do this? So we need to split this into tasks that we would do. So if he's got these 5 garden gnomes and they're all getting ordered, so the task is going to be placing each individual garden gnome. And so what we can do for this is usually when I do the product rule, I like to make these just little slots for each task. So task 1 is going to be place the first gnome. Or I guess maybe I'll write, instead of this, I'm going to do put gnome in position 1. And then we'll have position 2, position 3, position 4, and position 5. And so if we are completing this task of placing the garden gnomes, then the action between each of these is the word then. I would put a gnome in position 1, and then I would put one in position 2, and then I would put one in position 3, then position 4, and then position 5. So that means that it's going to be multiplication between each of these choices or each of these selections because of that word then. Now, something that is a little bit subtle in this case is that if I choose the first position 1, there are 5 gnomes to choose from. Now, the second action sort of does depend on the first action, because if I've chosen a gnome for position 1, that gnome is now removed from the collection of gnomes. So there's actually only 4 gnomes left. And the arrangement of those 4 gnomes is different depending on which gnome I chose for the first one, but the quantity of gnomes remaining is still 4 for position 2. So in counting, we don't really care about the specific individual objects. So what we actually care about is quantity of objects. So I'm just going to add that word up here to make that a little bit more clear. So the quantity of options should not change. And that's what we have in this scenario. So yes, if I put like the red-hatted gnome first, I'm going to have a different possibility for what the remaining gnomes are than if I did the blue gnome first. But quantities don't change. And that's what's really important here. So after I've picked the first 2 gnomes in position 1 and 2, I now have 3 gnomes remaining for position 3. Now I've picked 3, so I only have 2 left. And now I only have 1 last gnome for position 5. So I have this multiplication of 5, 4, 3, 2, 1. And what is that? 20 times 6 is 120. So this type of product is really, really common in counting because often we do have situations where we want to find the number of ways of arranging a collection where we can't repeat something. And that's, if you have a physical collection of distinct objects, you can't like breed one of them to just generate a second of the exact same thing. You can't put one distinct object in two different places. So we do get patterns like this quite often. And so just the last video in this section is going to be talking about this pattern.